Today we're going to look at how to use a graphing utility to draw a scatter plot, and if the data is linear, write the equation for a line of best fit. For today, I'm going to be using the Desmos online graphing calculator as my graphing utility, but you could do this with your graphing calculator and get the same results. So the first thing that we need to do is put this data into a table in Desmos. So to do that, we just click this plus icon to add an item, and we're going to add a table. And then we're going to go in and input our x and y values. So -2, -1, 0, 1, 2, and then put in the y values 7, 6, 3, 2, and 0. And that gives us our data. Our data becomes plotted here on our axes. We could zoom in a little bit to get a little bit better view of our data. But now we need to figure out, does this data appear to be linear? And if it is, what would the equation be for our line of best fit? Although we only really have 5 pieces of data, which probably isn't enough to actually determine whether this is going to be linear or not, from what we do have, it does appear that our data is trending in a straight line pattern. So it's following a linear trend, which means we will want to figure out what our line of best fit is. So to write the equation for our line of best fit, we're going to go into the next cell, and we're going to put in the following equation. So this is the equation that you will always use when you're trying to calculate line of best fit in Desmos. It's y sub 1 is about m times x sub 1 plus b. Now the reason why we're using y sub 1 and x sub 1 is because that's the information in our data set, right? So if our list had a different subscript, like x sub 2, y sub 2, you would use y sub 2 and x sub 2 here. So you need to make sure that this equation matches the data that you're trying to draw from. And you could even have multiple data tables, and this one is going to draw from whichever one you specify with your variable here. So what information do we get down here? So Desmos presents us with a few statistics and then also some parameters, and those are things that we want to look at for this equation. So first, our first statistic is this R value here, right? So this R value is something called the correlation coefficient. And basically what this does is it tells us how strong of a linear relationship there is between our data points. The correlation coefficient is a number that ranges from between -1 to +1. And if our data is perfectly linear, it will have a value of either -1 or +1, depending on the slope of our line. So if your correlation coefficient is a negative value, that means that your data trends in a negative pattern or would have a negative slope. And if your data is if your correlation coefficient is a positive value, that means that your data trends upward and has a positive slope. So you'd have a positive correlation coefficient. So +1 would be perfectly linear with a positive slope. -1 is perfectly linear with a negative slope. As your R value gets closer to 0, basically that just means that all of your data points are kind of spread all over the place, and there tends to be no pattern between our data, and it doesn't follow some linear trend. The other information that we want to look at are the parameters here. And we're given m and b. And those are the same m and b that we know from our regular slope-intercept form, with m being the slope and b being our y-intercept. In case you're skeptical, we could always graph the equation of a line that using those given values and see, is it actually this same equation? So if we say y equals -1.8x plus 3.6, we can see that this blue line here falls perfectly on top of our orange line, which was graphed as our line of best fit. So this is the correct values for our slope and our y-intercept for our equation for the line of best fit. So again, like I said, you're going to always use this same equation, if you're trying to graph an equation for a line of best fit using Desmos. But the only time it changes is if your ordered pairs, if your table of values is different. So you can see that this y sub 1 and x sub 1 in our line of best fit isn't giving us any values. That's because our table here, I just changed them to be x sub 2 and y sub 2 for demonstration purposes. You can see that if I change it to be y sub 2 is about mx sub 2 plus b, that our equation comes back. So again, you need to make sure that the values that you have here match the variables that are used in your data table.